Now that we've multiplied, we've divided, we've simplified, and we've added and subtracted like denominators and unlike denominators, now we're actually going to solve rational equations. We've been working with rational expressions and the fact that there's been no equal sign. So we're moving on. Now, something to note, last chapter, we did have something over rational equations. So this chapter, or this section, might be a little bit of a review from last chapter. For instance, let's say that I had x plus 4 over x equals -5. Okay, so the first thing I want to do, and you can have this x as x over 1, that's fine. The first thing I know I'm going to have to do is I'm going to have to get a common denominator, because 1 and x aren't exactly the same. Or I can eliminate and get this x here out of the denominator. So in order to do that, I'm going to multiply everything by x. And now technically this x over 1 I'd multiply by 1 as well, but we aren't going to multiply by 1. So looking here, I'm going to go ahead and distribute. So I have x squared plus, actually I'm going to break this down a little bit, sorry. I have x times x over 1 plus x times 4 over x equals -5x. So looking at this, I'm now going to go ahead and distribute. So I have x squared plus 4, because these x's cancel out. One's in the top, one's in the numerator, one's in the denominator, so they cancel. That equals -5x. Well, okay, where do I go from here? I notice that I have an x squared here. So I'm going to move this -5x over and set this equal to 0. So I have x squared plus 5x plus 4 equals 0. Well, I know that this is a quadratic, so I can solve by factoring, I can solve using the quadratic formula, or by completing the square. The option is up to you. I'm going to go ahead and solve this by factoring. I have x plus 4 and x plus 1 equals 0. So now I need to actually solve this. X plus 4 equals 0, so x has to equal -4. And x plus 1 equals 0, x has to be -1. Okay, here's the thing. There isn't a list of steps to go through. So the process is not the same for each type of problem, which can be frustrating at times, I understand. But it's just a basic algebra problem. That's what you need to think of it as. Okay, your goal is to get it to get rid of the fractions, combine like terms, maybe factor, and solve for x. So for instance, let's do another one here. Let's say that I have x minus 7 over x minus 2, x plus 2, and that equals 1/4. Now I know I said that not everything's going to be the same, but let's try to get it into a more generic form. Step 1, get rid of fractions. So in our case, we're going to multiply by x plus 2 and x plus 2. By get rid of fractions with a variable. So like that 1/4, we aren't going to be able to get rid of that right away. So over here on the left, the x plus 2 cancels. I'm left with x minus 7 equals 1/4 x plus 2. I can still work with get rid of fractions. If I want to get rid of the fraction here, I'm going to multiply by 4 to both sides. Because 1/4 of 4 is just 1. Step 2, distribute if necessary. Step 3, get variable on one side. Step 4, solve for x. I mean, this is pretty generic here. So now I'm going to go ahead and distribute. I have 4x minus 28 equals x plus 2. Get variables on one side. I have 3x minus 28 equals 2. 3x equals 30. X equals 10. So that solve for x doesn't necessarily mean that I'm going to have to use a quadratic. I could have a linear, which is what I have in this case. And I'm just going to solve it algebraically. So let's do another one in which that we have polynomials on both sides. X minus 2 over x minus 3 equals x minus 1 over x plus 1. So in this case, I'm still trying to get rid of the fractions. In order to get rid of the fraction on the left, I'm going to have to multiply by x minus 3. Whatever I do to one side of the equal sign, I have to do to the other. Well, that doesn't exactly eliminate this x plus 1. So I'm going to have to multiply by x plus 1. Again, whatever I do to one side, I have to do to the other. So I'm multiplying both sides by x minus 3 and x plus 1. On the left here, this x minus 3 cancels. I'm left with x plus 1 times x minus 2 equals. Now on the right, the x plus 1 cancels, and I have x minus 1 times x minus 3. Got rid of my fractions. Step 2, distribute. So I'm going to go ahead and distribute this. I have x squared minus 2x plus 1x minus 2 equals x squared minus 3x minus 1x plus 3. I'm going to go ahead and combine my like terms. All right, what do I do from here? Step 3 was to get the variables on the same side. So I'm going to go ahead and do that. So I have 0x squared plus 3x minus 5 equals 0. Okay, I'm going to rewrite this. All right, so I can go from here. So 3x equals 5. X equals 5 over 3. All right, let's do another one. x squared over x plus 2 equals 4 over x plus 2. For this problem, I gave you a little bit of an easier one, as you're multiplying both sides by x plus 2, and it happens to cancel. So x plus 2 cancels out on both sides. I'm left with x squared equals 4. I could solve this algebraically right here. And x could equal plus or minus 2. Here's the deal, though. I gotta check my answers. So technically, yes, it's x plus or minus 2. But if I have in the denominator x plus 2, this cannot equal 0. If I were to plug in that negative 2, that would equal 0. So because that happens, I know that my only answer is